Okay, I'm given a problem that says assume, I'm trying to click stuff here, assume that women's heights are normally distributed. Soon as I read that, I try to draw kind of a normal bell-shaped curve with a mean, so the mean given by 62.3 inches and a standard deviation of 2.9 inches. It says if one woman is randomly selected, find the probability that her height is less than 63. So that means I'm over here somewhere, right? 63. And I'm looking for this probability. And this is the whole thing of learning to read that z-table. So I know what I need to do, and that's what you're doing with the z-table, is you're standardizing, pretend I got that right under it, you're standardizing your mean to 0 and your standard deviation to 1. So basically what I'm trying to do is figure out what's that z value, and then I can look it up in the table. Well, we know how to do that with this formula. Z equals x minus mu over the standard deviation. Well, my x is the 63, the mu, the mean, is 62.3, and then all over 2.9. If I put that in my calculator, I get about 0.24. I round to 2 decimal places because that's what my table shows. So if I go here to 0.24, it looks like 0.5948. Let me zoom in that a little bit. So I look at the z, 0.2, and then I come under the 0.4 and I get 0.5948. So it looks like this probability here, okay, or even here, the standardized is 0.5948. Well, I can even do that in Excel. So in Excel, you can see the question here, my mean, my standard deviation. I found my z value, okay, and I'll post this file in Blackboard. I found my z value, and then what I did here, instead of looking up in a table, I simply used the norms. There's an S there because there's one without an S. DIST, okay, to look this value up. And Excel gives you kind of more of an exact value because you saw by our table we got what, 0.5948, and so that's my probability. So the second part of this question, the only thing that changes is it says if 38 women are randomly selected. So when you're given a sample size like that, then the only thing that changes in your formula is now you divide by the square root of the sample size. So in this case, we're going to have 63 minus 62.3 all over 2.9 times the square root of, what was our sample size, 38. And so if I throw that in my calculator real quick, divided by 2.9 over the square root of 38, I get 1.49. Okay, so if I'm rounding, so I get 1.49. Once again, I go to my table and I look for 1.49, and it looks like it's this value right here, 0.9319. So that would be the probability. And so if I go back to my Excel sheet, I did that here as well. You can see the only thing that changed in this formula is I square rooted my sample size and then used the same norms DIST to get my z value.